Hello and welcome to the second section of this course, Ansible Architecture and Design. In this section, we're going to be covering Ansible Inventories, how we can apply host and group variables, how we can simplify the group with ranges, how we configure the inventory to allow root connectivity, and also how Ansible can be used with different target configurations. In Ansible modules, we're going to take a look at some of the common modules available and learn how to interact and use them with the Ansible ad hoc command line tool. We'll learn about YAML, yet another markup language, and how we can use this effectively. Next up is Ansible playbooks, where we review the sections that commonly make up a playbook. We'll cover the various ways in which variables can be defined in Ansible. We'll look at facts provided by the setup module and also how we can create our own custom facts. We will use Ginger 2 for templating. Finally, we will take this knowledge and create and execute Ansible playbooks, where we will create a playbook that installs and configures the popular Nginx web server on both Ubuntu and CentOS, and templates the deployment of a web application for our use. Join me in the first video of this section, Ansible Inventories. We're going to take a look at Ansible Inventories, how they are used, and the different types of inventories. We'll be seeing how we can provide connectivity to our Ansible hosts via root. We'll be seeing how we can provide connectivity to our Ansible hosts via sudo. We'll cover host variables, better known as host vars. We'll see how we can simplify our inventory with the use of host ranges. We'll apply group variables to again simplify our inventory further. And finally, we'll make use of children groups. So, let's get started. Now that we have our environment set up, we can really get into mastering Ansible. Throughout this course, we're going to cover a lot of areas and there's going to be a lot of changes. For every example that we cover and every change, full examples are available under the Mastering Ansible repository. You can clone these examples to your Ubuntu-C system with the following git clone command. It's a directory structure with a directory for each of these sections. So I'm just going to go into this, and if I do an ls, we can actually see that there is a directory for each of the sections in this course. If we go, for example, into section 1, which we've already covered, and we have a look there, we have an 05. So this was the first video where we actually did changes. So if we go into the 05 video, and there were 3 revisions that we actually made when we were going through this video. So if we go into the first one, and what we have in here, each subfolder is self-contained with its own ansible.config and inventory. So we saw that an ansible.config in a current directory is the second highest precedence. So essentially, we can move to each directory and run Ansible from that directory to relate to the configuration that is actually within it. So here we are in the first revision. If we just recap here, that's our ansible.config, very simple, just pointing at our inventory. And if we look, this will just point to one host, CentOS1. So here, if we do an Ansible all -m ping, it's just going to ping that one CentOS host. If we go into revision 2 and we list, if you recall, in revision 2, we set it so that the host key check-in is false. And finally, from that validating Ansible installation section, if we go into revision 3, what we actually have here are the changes where we actually made to the host file. So from this one, if we do our Ansible all -m ping, And there we have it. So that pings all of our hosts. If we go to our starting point for this section, section 2, if we just go back a directory, back again, back once more, and into section 2, and we go into the first directory there for this video, Ansible Inventories. And if we go into revision 01, we're at that starting point, so we pick up where we left off in section 1. So just to show this here, and we have our hosts file, and again, and I'll do it with the /o here just to condense that. Okay, great. So just to recap here on our configuration, at the moment our setup is quite simple. We're connecting as the packed user to the Ubuntu-C system, and from there we're connecting as packed via Ansible to Ubuntu 1, 2 and 3 and CentOS 1, 2 and 3. We're going to configure Ansible so that we have root connectivity for all of our endpoints. The CentOS systems are a bit simpler, as for these we have root access. So if we go back and into revision 2 here, and we review our hosts, we have an Ansible_user host variable set for each of the CentOS hosts, stating that the user we will use for connectivity is root. On previous versions of Ansible, you may have seen this as Ansible_SSH_user. The best practice now is to omit the _SSH. When running our ping command against the CentOS group, this should now fail as we haven't set up our SSH keys. So I'll just clear the screen here. If we run this. Okay, so we have 3 failures for the CentOS host, and the Ubuntu hosts are still working as expected. Let's add our keys from our local packed user to the remote user for the CentOS box. We can do this with a bash loop to speed things up. After adding these in, the ping should work as expected. So we do a for host in 1, 2, 3, do SSH copy ID, and we want root at CentOS and then the host number, and done. And we just enter the password here. Okay, great, that's done. And let's give the ping a try. Okay, great. So now all of these are connecting, and with this change, our connectivity now looks like the following. We're now connecting from the Ubuntu-C as root for the CentOS hosts, and I've added a glow to these hosts to show that we have root connectivity. Let's look into providing root access to our Ubuntu hosts for this. We'll be using a different approach where we connect as the packed user and then become root. So if we go to revision 3 and look at the changes to the hosts file, here we're using the host var of Ansible_become, which allows us to become a super user either via sudo or su, and we're specifying the password. Later on, we'll discuss the use of the Ansible Vault for securing this in a better way. For now, let's just continue as this is. And if we run our ping command, again, we have connectivity across all of the hosts. After applying these changes, our configuration now looks like the following. The ping command that we just run is doing a lot more in the background behind the scenes. For the Ubuntu hosts, we're connecting as packed, and then we're sudoing as root. The endpoints for all of these now, they have a glow to signify that we have root connectivity. I recommend that you take a look at the following URL. There's a variety of useful content here which you should cover regardless of your setup. For example, if you're running on different SSH ports, have different SSH keys that you're using for different systems, something that's very common with cloud providers, or your Python installation is in a different location on the remote host, this page has a lot of useful information for covering these different scenarios. Pause the video and have a read through this. I'm going to change one of our systems intentionally to show how this could be of use. What we're going to do is change CentOS 1 so that it's running on a different SSH port. So we'll use 2222 instead of 22. So if I just connect across to CentOS 1, and let me just do that again. I want to connect as root. Okay, and let's edit the SSHD config. And if we go to this line, we can actually change the port here. So I'm just going to uncomment that and I'm going to change it to 2222. And note, if you see this line above, if you want to change the port on an SE Linux system, you have to tell SE Linux about this change. So we're just going to copy this command here. And we need the port number. So I'll save that file. And if I run this at the moment, this command is going to fail. And the reason it fails is because we do not have that SE manage utility. We can quickly resolve this. Okay, they are installed. And if we clear that and bring up our previous command, and if we run this now, okay, that's been successful. We are running on CentOS 7, so we're also going to need to open the firewall for these new ports. So we can do this quite quickly. I'll just clear and run firewall -command. We want the rule to be permanent. And we want to add port 42/TCP. And that's been successful. And we will reload the firewall. So again, -- reload. Okay, that's been successful as well. And the last thing we want to do is restart the SSHD service. Okay, so with that done, SSH should now be running on port 2222 rather than the usual 22. Let's check that. Easy way of checking this, if we SSH to 0 with -p to specify the port and put the port in. Now 0 is a shortcut for 0.0.0.0, which is technically localhost. And that's a good sign. It's giving us a warning there. And if we accept that and enter our password, the default password of password. Okay, great. So that's connected in. I'm just going to exit out of that and exit out of that, and we'll clear. With those changes in place, if we try our Ansible ping again, it should now fail for the one host, CentOS 1, and succeed for all of the others. The reason being, our current configuration expects the SSH connection to be on port 22, and we know we've changed CentOS 1 to be listening on 2222. Let's verify that we can actually connect from Ubuntu-C to CentOS 1 on port 2222. So what we're doing here is just doing a telnet on that port, and that's a good sign. We've actually got the SSH prompt there. The way we exit this, if you do Control and the right square bracket, press return, and then type quit. And what we need to do now is update our Ansible configuration so that we are accommodating this port change. If we go into revision 4, and if we review our hosts file, we have another host variable to override the Ansible port. So you can see that there, Ansible_port equals 2222. And if we run our ping command from this directory, once again, we can now ping all of the hosts successfully. If we look at revision 5, there's another way in which we can specify this. So you can actually see there, that we've specified it as CentOS1 :2222. And again, if we ping, it's all still working as expected. Personally, I feel that the first approach is a lot cleaner. It's better to use. So what we're going to do going forward is we're going to revert back to the previous method of using Ansible_port. After these changes, our configuration now looks like the following. Note the addition of SSH port 2222 to the diagram. As well as using SSH as the connection type, we can, where applicable, use local to connect to our local system, like we did when we were using the -c local with the Ansible tool in our validating Ansible video. If we take a look at revision 6, we have a control group with a local connection defined as a host var. If we ping the control group, we also have a success. There we have it. If we look at our host file again, we have commonality between all of the Ubuntu hosts and CentOS 2 and 3. Within our host file, we can simplify this using ranges. If we take a look at it as it is now, and then we move to revision 7, and we compare this, what we've done here is supplied ranges for CentOS 2 and 3. So we've used the open square brackets 2:3 close square brackets there. So that's signifying a range of CentOS 2 to CentOS 3. We've also done the same thing for the Ubuntu hosts. So Ubuntu 1 to 3. And we can verify that this is still working. So what we'll do a variation here. We looked at this previously. We'll do the --list--hosts. And we can still see that we have all of our hosts still available, and the context of that file is improving. We do, however, still have some duplication in the CentOS group where we have Ansible_user defined for both. We can mitigate this through the use of group vars, making every host in the CentOS group automatically receive the host var of Ansible_user equals root. We'll also look at doing this for the Ubuntu group. If we go into revision 8 and we compare this, you can now see these two extra sections. So we have CentOS::vars and we also have Ubuntu::vars. Within the CentOS::vars, we have the Ansible_user equals root. So now those group variables will be applied to every host within the CentOS group. With Ubuntu::vars, again, we have something similar. We have the Ansible_become equals true and the Ansible_become_pass equals password. So those variables will be assigned again to every one of the Ubuntu hosts in that Ubuntu group. So the range of hosts, which in this case is 1 to 3. Let's just validate this. We'll do this with a ping. We'll use the -o. Excellent. All still working as expected. If we look at our hosts file again, what we have now is a mixture of our control host and what could be considered our Linux hosts, the CentOS and the Ubuntu. It would be good if we can easily distinguish these Linux groups. Fortunately, Ansible has a children declaration which is very useful for this. So what we're going to do now is define a parent group of Linux with both CentOS and Ubuntu as the children. So if we go into revision 9 and we review the hosts file here, you can see at the bottom we have that group which is Linux::children. And for each of those we've specified CentOS and Ubuntu as the members of that group. And because of that, this group will inherit all of the members of the CentOS and the Ubuntu group. if we perform a ping against that specific group, we can see that we've targeted the Ubuntu and CentOS hosts. If you recall from section 1, we saw the all group. And just a reminder, technically all hosts are part of the all group. We can use this knowledge to apply variables to all hosts using the all::vars group var. We have a look at revision 10, and you can see at the bottom there that what we've done is set the Ansible underscore port to 1234. Now, of course, 1234 in this case is not a valid port for SSH, and our connections will fail, but it's a good way of demonstrating this functionality. Now, something which is useful to know here is if you look back at CentOS 1, we have an Ansible port entry specific to that host, and specific host variables take precedence overall. So where we have the Ansible port specifically set for CentOS 1, this will take priority over the all value. So now, if we run our ping against all of the hosts, they should all fail with the exception of CentOS 1 and obviously Ubuntu-C, which is not using SSH, it's using a local connection. We can apply group vars to a parent, and again, all children will receive the vars, but as we saw with the all group, host-specific host vars, like the one we have for CentOS 1, take precedence. So if we look at revision 11, you can see here at the bottom, so rather than all::vars, we have Linux::vars. Again, we've got that Ansible underscore port set as 1234. And now, if we issue this against all and we ping, we should have the same outcome. Ubuntu-C is a success and CentOS 1 is a success as well. Going forward, we're going to remove those entries. In the Validating Ansible video, if you recall, I mentioned that the inventory is most often written using the ini format, but it can also be written in YAML or JSON. Let's take a look at the host file as it is now. And if we go into revision 12, what we actually have here is an equivalent of that hosts file in YAML. In YAML, a file is defined with the 3 dashes at the top and ideally with 3 full stops at the bottom. We have our groups at the start of the file, so the root of the indentation, you can actually see the control, CentOS, Ubuntu, and Linux groups. Under this, we have a variety of different keywords, so we have hosts, we have vars, and we also have children. So the hosts are, this bit is quite simple. This is the list of hosts for each of those groups. So we can actually see here, we have Ubuntu-C under the control group. We have CentOS 1, 2, and 3 under CentOS, Ubuntu 1, 2, and 3 under Ubuntu. And subsequently, if we go back, individual host vars are indented further again, so we can see the Ansible underscore connection, which is indented underneath this entry for Ubuntu-C. The Ansible underscore port is the equivalent. For group vars, so on the same level as hosts, we have a vars section. So this is actually stating that this is the group vars for the CentOS group there. And within this, we have the group var of Ansible underscore user equals root. Finally, at the bottom, we have at the same level as the host and vars, we have this children declaration, and we're stating the actual children here. If we look at the ansible.config, this has been updated, so you can see that the inventory here states hosts.yaml.yml. The important thing here, you have to have that extension. It has to be .yml or .yaml. Ansible uses this to actually work out the format of the file and what parser it actually needs. So if we run this, and that's using the YAML format, and again, all working as expected. If we go to revision 13, what we have here is the JSON equivalent as well. And I'll just pipe that through more. And again, because we know the layout of these files, we've become very familiar with them by now, it's pretty easy to actually work out, and it follows a very similar structure to what we actually saw in the YAML file. And in fact, it is very easy to actually convert from YAML to JSON using a variety of tools. There's a plethora of online tools for this, or you can actually do it from the command line using Python. The JSON format is a lot less forgiving than YAML, and if you look there, for example, where we have these individual host entries, you need to actually include these with a null marker there. And it's very important with JSON that your commas are included in the correct place, so we can actually see a comma ends here and there's no comma here. And again, if we look at the ansible.config, this has been updated so that it states hosts.json, and if we run our ping command, again, that's successful. Okay, so if we go into revision 14, and what we've done here is reverted our ansible.config back to the standard hosts file, and within this we still have the host.json and the host.yaml. What I just wanted to show you here was you can use with the Ansible command line tool, you can specify an inventory, and that inventory flag will also work with the standard ini file, we know that, but it will also work with the JSON and YAML file. So let's do something simple. So if we do Ansible all, and we specify our inventory here of hosts, -m ping, and we'll do -o. Okay, so that's working with the standard hosts file. Let's add in YAML. And you'll notice there, I did actually type YAML, Y-A-M-L. You can actually do this in two ways. So you can have it as YML, or you can have it as YAML. And just as I did that, we'll actually prove this. I'll move this to YAML, and we'll repeat the command. Okay, and that's working as expected. And lastly, we'll use the JSON version, and again, that's working as expected. Another useful command line option to be aware of for overriding variables is the -e or --extra-vars parameter. This can be used to override existing variables set in the inventory. So we set, for example, the Ansible port. If we just recap and bring up our host file, we have that Ansible port set to 2222. And what we can do here, if we pick the Linux group and we attempt to ping, and we give the -e option, and I'm going to set this, so Ansible _port, and what I'm going to do here, I'm going to set this to 22. So what will happen now, it should succeed for all of the hosts with the exception of CentOS1, which we know is listening on 2222. And there we have our failure, and we have success. And correspondingly, if we inverted this and did this to 2222, it will succeed for one and fail for all the others. Just like that. Okay, so that's the end of this video.